it's recording, isn't it? Okay, so we talked about the first one that you should have gotten negative 8/3 and negative 2.7. What did y'all get for this factor right here?
3x squared plus 5x
Minus 8. And then instead of using the quadratic formula, we could factor that into 3x plus 8 and x minus 1. And then we set each one of those equal to 0. 3x plus 8 equals 0 and x minus 1 equals 0. So this one, x is going to equal negative 8/3. On this one, x is going to equal 1. So that's how we got these. Now, also, you could use quadratic formula and get the same thing. Okay, so let's look at number 2. When you bring down the 1, this is negative 5. You get negative 4. When we combine them, negative 4 times negative 5 is 20. This will be negative 6. Negative 6 times negative 5 is 30, and we get 0. So what's the factor?
squared
Minus
4x
minus 6. Everybody get that okay? All right. And then you had to use, this one did not work. 3 times 2 is not going to get you 4, and 1 times 6 won't get you 4. So we're going to have to use the quadratic formula. So x equals the opposite of b, which is 4, plus or minus b squared, square root of b squared, which is 16, minus 4 times 1 times negative 6 over 2 times 1. Okay, so 4 plus or minus square root, what did y'all get for underneath there? 16 and 24? Is that 40? 40. Did everybody get 40 here?
Yes.
Okay, over 2. Okay, now here's the tricky part. 40, you can simplify. 40 would be 4 times 10. We make a factor tree. And then 4 is 2 times 2, and 10 is 2 times 5. And circle the pairs. So we can take a 2 out of here. Y'all remember this?
Mm-hmm.
Okay, so 4 plus or minus 2 square root of 10. What's left stays inside. 2 times 5 is 10. That stays in. Over 2. Then you can reduce the 4 and the 2 and the 2. Okay, so we reduce it to what? 2
plus
minus
square root of 2
over 1, which we don't need, do we? Okay, so one of the zeros is 2 plus the square root of 10, and the other one is 2 minus the square root of 10. And did anybody get a decimal for that? What's 2 plus the square root of 10?
5.2.
Say that again.
5.2.
Okay. And the other one?
Negative 1.2.
Okay, questions on that one? The tricky part was the simplifying the 40, square root of 40. Okay, number 3. Synthetic division. Looks like that's going to be okay. All right, so we ended up with 0, and then so what's the factor for this one?
x squared minus 2x plus 2.
Okay. That one cannot be factored, so we're going to do x equals the opposite of b, which is 2, plus or minus the square root of b squared, 4, minus 1, minus 4 times 1 times 2, all over 2 times 1. So we have 2 plus or minus the square root, and we end up with 4 minus 8, which is negative 4 over 2. And the square root of a negative is imaginary, so 2 plus or minus what? 2i. Square root of 4 is 2, and then the square root of a negative is an I, all over 2. And then these 2's all cancel out.
So you just left it plus or minus I.
No, you still have this 1. So you have 1 plus or minus 1i, or just I, over 1, which you don't need the 1 in the bottom. So you end up with 1 plus or minus I. So one of the other factors is 1 plus I, and the other one is 1 minus I, or actually zeros or x. And that's not an x-intercept because it's imaginary.
So
So-
it never touches the X.
Right. Okay, so if you graph number 4, I think I already have it graphed. Is this number 4? Yeah. Did y'all graph it? You want it to go through negative 2.6 and touch at 1. Like that. Okay, and that makes sense because we had two factors, 1 and 1. So that's why we had a double root here. Okay, then the roots and zeros are all the same thing. X-intercepts. Only problem is when you have imaginary, you're not going to have an x-intercept. But put the next one in. Okay, this one crossed at 1, 2, 3, 4, 5. Is that right? Negative 5? Yes, that one's correct. And then somewhere around here. 1, 2, 3, 4, 5. Is that one? No, that one didn't. Yeah, 5.2 and negative 1.2 and negative 5. Okay. Now this one, though, is the one we're concerned about. So x to the third minus 6x squared plus 10x minus 8. Okay, so it makes a bend here, but it does not 1, 2, 3, 4 cross or touch the x-axis.
Computer.
So why does it do that? Oh, how come? Why does it do that?
Because
Because what?
it's imaginary.
It is imaginary. When it's imaginary, it's not going to cross it. It keeps it from touching the x-axis. Okay? And we're just going to run out of steel anyway. Just let it run out. Yeah, I don't have mine. I must have left it at home. I don't have my cord. Okay. So this is called the fundamental theorem of algebra. If you turn the page. If a polynomial function p of x is of degree n, then the related equation p of x equals 0 must have, if it has degree of n, it's going to have n roots. So if the degree is 5, how many roots will it have? 5. If the degree is 2, how many roots does it have? 2. Now they don't all have to be real. Some of them can be imaginary. So quadratic equations of degree 2 must have 2 roots. Cubics have to have, quartics have to have 4. There you go. Okay, some solutions can count more than once, such as a double root. In these cases, we say that the solution or root has a multiplicity greater than 1. Got 1, 2, 3 I's in there. Multiplicity. Okay, and then real solutions. Oh, let's go down here. Some solutions involve non-real numbers. Okay, with imaginary values. And when non-real roots are present, they must come in pairs. So if you have, like, you know how we had 1 plus I and 1 minus I? It has to come, if you have non-real, you can't have just one imaginary solution. You have to have 2. Okay? Now you can have one real solution at 1. And then you would have maybe 2 imaginary, something like that. Okay, that's for the algebra part. If you're graphing it, okay, real solutions show up as locations where the graph intersects the x-axis. Okay, at a double root, the graph will touch but not cross the x-axis. That's what it's going to look like on the graph for a double root. Non-real zeros of p of x do not show up as x-intercepts. Instead, they create bends in the graph that prevent it from crossing the x-axis. Just like that last one we did. Okay, so on number 5, it says a quadratic function with one real zero of multiplicity 2 or a double root. Okay, so if it's quadratic, how many roots are we going to have?
2.
2 roots. 2 roots. Okay, and this says that we have a double root. Okay, so what if we wanted to draw one? What would it look like?
And multiples.
See, just like that. I actually touch it and melt back up. Okay, or it could be underneath, and it can cross here. It just will not. It's just going to touch it and come back up. Now, why does that have 2 roots? It looks like 1 root, but it really has 2 roots. Why?
Because it's not going through.
Right, because it's a double root, so it's going to have 1 root twice, the same root. Let's say this is at 2. It's going to have 2 roots at 2. Or the factors will be x minus 2, x minus 2. Okay, how about number 6? A quadratic function with a negative leading coefficient and 2 non-real zeros. Quadratic, so it's got 2 roots. Negative leading coefficient. What does that mean? How's it going to end? Down. Okay. And 2 non-real roots. Imaginary. 2 imaginary roots.
It's going to go up and down, not touching it.
And not touching it. So, would I draw it here? No. Where would you draw it?
So that it doesn't cross the x-axis.
Underneath. Underneath it. Somewhere underneath it. Like that. What'd you have, Bryce?
I drew one.
So that means it's 2 2 imaginary roots because it doesn't touch it at all. Okay, cubic function with 3 distinct positive real roots. So what does that mean?
Crosses on the positive side.
It can cross anywhere actually, and it will eventually cross on the positive side. Something like that. Yours could look a little different. It doesn't say whether it goes up or down. I'm assuming if it doesn't have a negative leading coefficient, that it's going up at the end. Okay, a cubic function with 1 real zero and 2 non-real zeros. Now it's got to cross it once
And then touch.
and then not touch or cross at all, but have some bends in it, right? So, how about if it crosses it here, come up, then we're going to go back down, but it's imaginary, so we can't touch it or, yeah. Okay. Okay, a quartic, 4th degree. How many roots?
3. Oh, well,
4 roots, okay. 2 distinct real roots and 1 double root. So it's going to cross it twice and touch it once. And it could look like that. That would have a negative leading coefficient. If you didn't want to have a negative leading coefficient, you have to flip it. Is that okay? So it's crossing it. There's your 2 distinct real roots. There's your double root. Okay, a quadratic function with 2 distinct real roots and 2 non-real zeros. Are your distinct ones? Then what would you do?
Make a bend, but not touch the x-axis.
Do you not have your yellow sheets? I'm sorry.
No, I accidentally, I can't
Okay.
find my binder.
Okay, we're stopping here.